Alright, cooling water section 6, description, components. Locomotive cooling system is a pressurized water system that maintains essential engine operating temperature throughout the load range with a wide variation of ambient temperature. The system also supplies heat with the cab heater, the water cooled air compressor, see figure 6.5. Cooling system consists of the following principal components: water storage tank, water pump, water inlet headers, water discharge header, flow control valve, radiator sections, cab heater, lube, oil cooler, valves, and interconnecting pipes. Your system operation: water storage tank located just forward and slightly below the radiator panels contains the supply of working coolant in the system. Two filling openings equipped with spring-loaded caps are located near the top of the water storage tank. The openings are situated to allow the water to add to the tank from either side of the locomotive. Note: some of the locomotive models may be equipped with only one water fill, usually on the right side of the locomotive. Water leaving the storage tank drawn downward through the vertical tubes lubricating oil cooler, then conducted in the suction side of the engine driven. Central figure water pump, simplifying with the piping system draining the lubricating oil cooler, is bolted directly to the storage tank at its lowest point. The cooler is supported with a locomotive platform, 3 adjustable feet. Water discharge from the pump enters the lateral passage-free cover of the engine, where it is distributed inlet water header for the turbocharger intercoolers. The inlet water heaters are one along each side of the distributed cool water into the cylinders. These headers are made up of the 8 sections with individual removable and removable. Each section is bolted into the cylinder and connected to the adjacent section of the dresser couplings. The cylinder contains a wet type liners surrounded by a vertical passage. Incoming water flows downward through the passage, upward, up and out of the additional passage of the cylinder head. Engine intercoolers, which remove the heat from the combustion air, are constructed with a fabricated steel case with enclosed fin of the tube type of the radiator core. Cooling with the water-free end of the cover enter for the bottom of each of the intercooler. Passes vertical 3 times through the core and then discharges at the top of the cooler. Water flowing at each intercooler is limited by an orifice in the cooler discharge opening. The turbocharger located at the free end of the engine is to receive the cooling water through the tube opening the top surface of the free end of the cover. The openings are aligned with the opening in the base of the turbocharger bracket. The mated connection is sealed with an O-rings with a discharge from the turbocharger at 3 openings top of the exhaust gas inlet valve. These openings are turned and connected with the discharge pipe from the left intercooler. Water is supplied with the air compressor with the cab of the heater with the pipe connected with the inlet water heater on left side of the engine. Return to the system through the pipe that extends along with the right side of the engine and connected with the bottom of the header with the lube oil cooler. The desired fuel heater, which is operational equipment but may be connected to this in line. The compressor is supplied with a pipe connected with the flow of the control valve discharge with the radiator return pipe. The discharge water header is centrally located lengthwise over the engine. The discharge opening connected with the junction box at the top of the right of the intercooler branch pipe welded into the header are connected to the individual cylinders by the dressing fittings. To use water flowing in the intercooler's turbocharger discharge water header combines at a junction box and connected with the flow of the control valve. The flow control valve is mounted with the forward left corner of the water storage tank, regulating the temperature of the system. Routing of the water flow from the engine follows figure 6.5. Directly the water storage tank with a minimum engine cooling is required. To forward the 2 radiator section with partial cooling is required. To all radiator sections when full engine cooling is required. Water cooled with the radiators then returned to the storage tank. The minimum engine cooling, the flow of the water radiator is cut off. The flow control valve of the water left of the radiator section piping is quickly drained to the storage tank by gravity flow. Cooling water treatment. In order to maintain the efficiency of the diesel engine, cooling water systems protect against corrosion, erosion, the barrier smell in contact with the fluid. Water should be kept clean with a proper limit alkalinity. Hardness inhibitor with a concentration may be accomplished by using sodium chromate water treatment compound concentration between 4,000 parts per million to 2,500 parts per million. And drying the treatment should be complete with dissolved being added to the cooling system. Solution should be prepared in open containers with adequate ventilation. Parts and decks should be washed and cleaned with the dryer and slipped on compound. Warning: chromate compounds are toxic. Suitable precautions must be taken by the persons handling them to avoid inhaling the fumes or dust to avoid skin contact with solids. Coolant should be checked with a sufficient frequency, particular unto Until its condition reaches a steady state, ensure the compound with the recommended limits. Check the periods should not exceed 1 month. C.5. Limited presence of non-ferrous components in the cooling system. Coolant should become contaminated with sludge, dirt, or oil. Cover the contamination should be found with a corrected system cleaning described under cooling system maintenance. Approximately 1 pound of commercial chromate treatment, such as Nalco 38 Dearborn 517 or equivalent, is required for each 20 gallons of raw water in order to allow the gradual dilution of the concentration. Raising the water level in the expansion tank of the locomotive system from low to idle to full to idle requires approximately 60 gallons of water. Water treatment test kit is available under the GE CAT number 147X1225. Using the kit simply four-step procedure permits the maintainer to read from the table of the number of pounds of chromate treatment which should be added with the locomotive cooling water system to restore the 4,000 parts per million concentrate. Alright, filling. Locomotive cooling water system can be filled with either two fill openings located near the top of this water storage tank, with the openings situated to allow the water to add and from the either side of the locomotive. See Figure 6.5. Note some of the locomotive models may be equipped with only one water fill, usually located on the right side of the locomotive. Two water level sight glasses are located on the water storage tank. They are marked to indicate the normal water level that occur throughout the various operating conditions of the cooling system. Locomotive is operating fluctuations will occur with the level of the water sight glass in the storage tank. This is normal and is caused by water in varying amounts being diverted with the storage tank to the radiator during intervals of cooling. When filling the system from the completely drained condition, adjust the water to properly level the engine idle to allow the trapped air to vent from the system. Note, water will be forced from out of the fill pipe for the pressure system. Fill caps are removed with the water levels above the full idle mark. Mark on the gauge if the system is excessively hot before removing the caps for the draining some of the water from the system. Allow the system to cool down. In either case, slowly turn the fill caps to allow the system pressure to be vented before removing the following flow caps. There are the caps. Caution: not operate the locomotive if the water supply drops below the level of the marked low idle low load on site gauge. The engine may overheat, become damaged, and operated with the water below the indicated levels and the treated water for the proper level of the engine idle. Alright, drain. See Figure 6.5. The cooling system equipped with 3 manually operating valves. The main system drain valve located near the base of the lubricating oil cooler. 2 cab heater shut-off valves B and C located in the operating cab near the cab heater. And because this is a pressurized system, drain time will be greatly reduced by filing fills if the system is vented to atmosphere by one of the fill caps. The system can be completely drained by opening valves A, B, and C. In the freezing weather, 1/4 of an inch drain plug must also be removed from the water pump impeller casing. Caution: to prevent the cab heater from core over the freezing during the extremely cold weather, heater valves B and C must remain full open at all times. If it's an emergency, the valves must be closed. Pipe connections in the heater core must be loosened to permit the core to drain. Flow control valve. The flow control valve has no manual adjustment. The valve is made up of 8 thermostats, 2 piston type valves, and filter screen. Also housed with a fabricated steel case. Valve is mounted over an opening in the water storage tank with connected to the engine by a single pipe of the radiator section with a 2 pipe with the removal of the core permit access to the control valve's internal parts. Rectangular covers over the 8 thermostatic unit tray, 2 cylinder covers over the V2 piston type valves, and 1.5 inch pipe boss is provided outsider of the case permit installation of the temperature test gauge. Alright, your valves within the case. Thermostat valves. The thermostat function of the two-way valves when the water temperature is below the operating point with Figure 6.1 with the passes water directly through their cylinder body for the water tank below the water temperature. And with the temperature sensitivity, the compound bulb located at the top expands, overcoming the spring pressure, forcing the skirt downward. As the skirt moves, the opening of the bottom of it becomes more and more restricted within the previous closed opening of the top of the skirt. Increasing in size permits water pressure to start with the building of an adjacent chamber. Figure 6.1 shows your opening thermostat. It has a bulb, a spring, a seat, and a skirt. In a closed position, partially open position, skirt moves downward. Are your piston type valve. Condition flow of the radiator with the control of the two snap action piston type valves V1 and V2 shown in figure 6.2, vertically mounted within the case of the valve with each of the upper lower port piston connected by a stem. These valves are identical with the interchangeable center portion of each of the valves, however, the permit the water of the leaks past the upper piston to return through the valve of the storage tank with less of the leakage not affect the operating system. To ensure the aggregate operating weight of each of the valve is held with close limits during manufacturer's successful operation system during freezing, whether depends upon the water flow through the radiator sections being either by higher rate completely off with a trickle of the water over the permeator to back off of this radiator's ice would form for the tubes. Snap action of the piston type valve accomplishes this purpose. Combined, the flow control valve regulates the temperature of the cooling system, the direct water flowing with the flow of the manner. The minimum engine cooling system is required, figure 6.2. Water discharge for the engine enters the chamber A to flow with downward through the filter screen with the thermostat. Since the thermostats are below operating temperature, water passes through their low opening of the tank. When partial engine cooling is required with the engine discharge, water temperature arrives with the thermostat being operated with the downward movement. This skirts partially to restrict water flow with the tank to the tank. At the same time, the openings of the top of the lower skirts allow the water to enter chamber B. The pressure now begins to develop in the chamber B with the thermostats have moved from their skirts, ensure the cause of the pressure of the reach approximately 4 psi. Valve V1, the valve V1 snaps upward and limits the travel. The chamber B now opens down to chamber C. The chamber C is closed to the storage tank by a lower piston. Valve V1 water flows from the chamber C through the pipe connection to the radiator section 1 and 2. At the moment the valve V1 opens, the water pressure for the chamber B and C falls somewhat below 4 psi. Then valve 2 does not open. The valve 1 remains up. However, because of the area of the bottom of the upper piston is that exposed to the pressure still large enough to hold volume valve 1 up, even the reducer of the pressure. If the cooling demands are now satisfied with the water temperature remains approximately constant, no change of the valve position take place. Small variation cooling requirements are satisfied by slightly opening and closing closing the thermostat to moderate the flow. If cooling requires should foul off the thermostat, will cover the opening on the top of the skirt land with the extent of the tank sufficient to lower the pressure of chamber B and C. With the point where the gravity will pull valve 1 down to closed position, resulting again in the situation depicted in figure 6.2. Air with the storage tank enters chamber C to vent the air from the radiator, permitting it to drain. 3. When full engine cooling is required. If the valve 1 opens with the engine discharge, water temperature continues to rise. Thermostat will further restrict the water flow to the storage tank, at the same time allow increased flow with the chamber B and C pressure. In these chambers again begins increase while the pressure reaches approximately 4 psi. Second time, valve V2 will snap upward with the limits of the travel. The travel C opens the chamber D. When the chamber D is closed with the storage tank by the lower piston V2, valve 2, while water flows for the chamber D through pipe connection with the radiator section 3, 4, 5, and 6. Water is now flowing with the radiator sections, resulting in maximum cooling by the system, and before the system variation, cooling requirements are satisfied by slight opening and closing of the thermostat to modulate the flow. Alright, 4. When the engine cooling requirements decrease. When cooling requirements decrease sufficiently, the sequence of the operation previously described will be in reverse. Thermostat will gradually reduce the water flow with the reduction of the pressure, chamber B, C, and D. Because of the higher rate of flow, the greater decrease in pressure will occur when the chamber D with the clouding of causing the valve V2 to close first, then V2 closes the flow of the water over the radiator 3, 4, and 5, 6 will shut off. Same time, the radiator section will be vented with the storage tank with the lower piston with the volume to valve V2, permitting the water remaining in the section quickly drain the tank. Water pressure in chambers B and C will increase somewhat with the closing valve of the valve 2. Thus, V1 will reopen and the cooling requirements continue to decrease. The thermostat will further reduce the chamber B and C, with the pressure of the C becomes sufficiently low. Valve 1 will close, shutting off the flow of the water radiator section 1 and 2. As with valve 2, the radiator sections are vented with the storage tank through the lower piston valve 1, thus permitting the water to remain in the section quickly draining into the tank. Inspections and repairs. It's not necessary to drain the water system and inspection repairs parts of the flow control valve Since water is only present with the valve during the engine operation, proceed as follows. Figure 6.1. Remove the covers of the thermostat valve 1 and 2 valves. Check the piston type valve with the free vertical movement of lifting, releasing the movement. If it's not free, check the valve surfaces of the cylinder walls by scoring or foreign materials polish the scored surfaces up to 320 grade or emery cloth. Remove the dresser coupling with the discharge water line from the engine to the flow control valve. See Figure 6.1. Remove the collar with a short length of the pipe of the flow control valve to allow the removal of the filter screen. Pull out and clean the flow control valve filter screen. Inspect the thermostat to make certain that they are properly seated. Remove the thermostat, test the proper operation of the aggregated hot water seat data with the proper temperature value to renew any of the defective units. Reassemble the parts inspection cover gasket with the collar O-ring. Renew the gasket O-ring with the damage to replace the covers. Alright, your safety device, engine high temperature switch. The engine high temperature switch moved onto the flow control valve thermo-electrical safety device. The functions alert with the operator, which should be the engine temperature, will become excess of the temperature of the water discharge of the engine, reach of the temperature of the setting of the switch, electrical contact will close with the engine, using a light or a belt in the operator's cab to show the proper operation of the switch for being inspected with the test of the hot pot. Switch in place, remove the cover plate, check with the make certain with the electrical connections, with the secure with the contacts with the good condition. Contacts burned and pitted may be addressed with a circuit de-energized using a small fine flat file. Do not set the switch on the locomotive by covering the radiator inlet screen with the can damage for the engine air filter system. See data switching settings. Caution: when all conducting the test, do not allow the temperature of the cooling water discharge from an engine to exceed 205 degrees Fahrenheit. Should the switch require adjustment if the closing opening setting will be raised or lower simultaneously with the turning the external adjusting screw on the switch case, differential setting of the switch can be adjusted with the changing of the magnetic air gap of the movable comm deck. However, the adjusting is quite difficult to make. This should not be tampered with when adjusting the switch of the locomotive. When checking the engine with high temperature switch and immerses within a switch tube with a pot with the agitated water, slowly raise the temperature until the switch contact closes, lower the water temperature until the contact opens. If necessary, reset the switch to operate proper opening and closing the valve. See data. Low water pressure. The low water pressure shutdown automatic safe device should be shut down in the engine in the event of the cooling water failure. The device is mounted on the left side of the engine control governor pipe of the engine cylinder inlet water header. If the pressure of the cooling water supply with the engine cylinder drops below the required safety operation of engine and the water pressure device, if the function shut down the engine for operation adjustment details of the engine control governor instructions. Your radiator is made up of 6 individual sections, 3 on each side of the locomotive, mounted in the slope of the downward locomotive center line with the outer side screen mounted on the upper side of the radiator, protected from the damaged radiator sections are alternately numbered as starting with the water storage tank with the odd numbers are of the right side of the locomotive, even numbers on the left side. Pipe connection, chamber 5 with the flow control valve, inlet radiator section 1 and 2. Another pipe with the connection of D, chamber D with flow control valve and inlet radiator section 3, 4, 5, and 6. Pipe connections of the radiator sections are made with the dressing fitting to permit easy removal. Cool water flows from the radiator section through the respective drain header pipes to the water storage tank, and a small pipe with a connected with the parallel to the large drainage header assure the complete draining of the locomotive is not on a level track when the locomotive is not on a level track. Alright, your daddy water capacity 290 gallons, flow control valve thermostat starting open at 165 degrees Fahrenheit, fully open at 180 degrees Fahrenheit. Valve and skirt travel closed to fully open, minimum 11/32 of an inch. Engine temperature switch close, contact close at 200 degrees Fahrenheit plus or minus 2 degrees. Contacts open at 193 degrees Fahrenheit plus or minus 2 degrees. Torque values, water dump pump driven gear, not 200 to 220 pounds a foot torque. Alright, this shows your 6.2 shows your flow control valve operating condition, minimum operation. Thermostat operated, and then flowage from the water storage tank, the flowage fluid flow from the engine A, B, C, D. 6.8 shows flow control valve operation condition, partial engine cooling required. And then it shows flow control valve operation condition, fuel full engine coolant required. Next, it shows your locomotive cooling water system radiator over top of the top, and then into the cylinder banks. Chapter 7, Air System. Period.